So now let's see one more example where we will be making the regular expression. Let's take the pen now. Yes. We want set of all string whose length is going to be 2 mod 3, which means when we divide it by 3, remainder is going to be 2. So what are all the strings can come? 2, 5, 8, 11. See, on 8 when we divide it by 3, remainder is going to be 2. Okay, so this is the pattern which is coming. So what you can do is, see, set of string whose length is going to be exactly 3, we have we already made the what regular expression. What was it? See here, you can see here. See, this is the regular expression for set of all string whose length is divisible by 3. Okay, now what we want uh, length is congruent to 2 mod 3. So it means, see here, if I could write like this: a plus b, a plus b, a plus b, and then whole star, it becomes set of all strings of length divisible by 3. Okay, but what exactly we want? We want when we divide it by 3, the remainder should come as the 2. Length of the string should be like that. So if I put like this, a plus b and then a plus b. Now check it. In place of star, when we put 0 now, it will be length will become as, see, this whole, this thing will become as epsilon and this will become as 2. So 2 length string is going to be happen. Now in place of star, if we put 1, then this part is going to be 3. Okay, this part is going to be 3 and this part is going to be 2. So 3 plus 2, 5 length string is going to be. Okay, now in place of star, if we put 2, how many length string, how much length string we will get? We'll get what? 8. Because see what happens, a plus b, a plus b, a plus b. If I put whole star 2, it becomes what? 6 length string and 2 length string also concatenated. So overall it becomes 8 length string. Got it? So this is how we can draw the regular expression for such type of strings. Now let's do one other type of examples. Here also sigma is going to be, what is happening, a comma b. Okay, now we want set of all strings in which number of a's are going to be exactly 2. Exactly 2. Okay, so how can we draw the regular expression? We want exactly 2 a's. Now before it any number of b can arise. After this a also any number of b can come. Before this a also any number of b can come, and after this a also any number of b's can come. So this is the regular expression for string of length exactly, yeah, string in which number of a's are exactly 2. Got it? Now do some more example. Let's take in which number of a's are going to be at least 2. At least 2 means number of a's can be either, sorry, at least 2 means either 2, 3, 4. Okay, got it? Number of in, we want the regulation for the string in which number of a's should be at least 2 or more. Okay, at least 2 itself means or more. So at least two A should be there. Before it, any number of B can come. After it also any number of B's can come. And once 2A has arrived, after that any number of A or B's can come. Got it? So this is the regular expression for at least two. Now you might think, sir, why can't we write like this? A plus B whole star. A, A plus B whole star. A, A plus B whole star. It is already at least 2A. See, before this A, any number of A's, any number of B's can come, anything can come. After it, anything can come. After this, anything can come. But the constraint is at least two A should be there. So yes, this is absolutely fine. No problem at all. So what I mean to say by showing this example, that many regular expressions are possible for the same language. Many finite automata are possible. Many regular grammar is also possible. Got it? So you might write like this also. See, B star A plus B whole star, A plus B whole star. This one is also correct. Got it? But the constraint is the number of A in the string should be at least 2. Okay, let's see one more example. Now do for number of string in which number of A's are going to be at most 2. Now you have to do for at most 2. See, for exactly 2 what you did, check it. If number of A's were exactly 2, how we did? See, exactly 2. See, before this A, any number of time B can arise, and before this A also any number of time B can come, and after exactly 2, after this also any number of B can come. This is what we did in exactly 2. Got it? Now we have to draw for at most 2. Now see, if I write in place of A, if I write A plus epsilon or epsilon plus A, see, A plus epsilon, what it becomes? We can, now let's do, I'll see, A plus epsilon B star, A plus epsilon B star. Okay, see, if this is the string in which number of A's are going to be at most 2. How? See, if we want one number of, if we want the string in which number of A's are going to be exact 1, at that time A can come from here and epsilon can come here. By this we can find A as a number of A's are going to be 1 in the overall string. If we want the string in which number of A's are exactly 2, A can come from this and A can come from A plus epsilon also. This is also true. Now if we want that number of A's are 0, so epsilon can come from here also, epsilon can be selected from here also. Then got it? So this is how we draw the number of A's are at most 2. Regular expression for at most 2. Yes. Let's do one more example. Number of A's are even. What I want, set of languages, set of all strings in which every string containing number of A's are even length. Got it? So what is the language which can be present? See, epsilon A can be 0, epsilon A or B or B A and so on. Got it? Now let's draw it. A's are going to be even, so I'll put two A's there. Now before it any number of B can come, after it any number of B can come, and after it also any number of B can come. Now if I put a star to it, it becomes the string in which number of A's are going to be always even length. Please check it. So we can find B A B A B. When I put a star equal to, if I put a star 1, it becomes like this. If I put a star 0, it becomes epsilon. So epsilon is also included here. Got it? Now, now the problem here is A's are even. See, language contain many things. It can be either 1B or 2B or 3B or any number of B's. But this is not handled by this regular expression. So what we will do, will union B star. Got it? Either this or this string. I also want to check for B's also. Only B can also become na. That is why I am taking this into consideration, because see, this is taking care for epsilon and anything containing two A's. This thing will be handled by this part, right? Now what if this type of string comes? What if this type of string comes? So for this I am writing B star, either this or this can also come now. That is why I wrote it. Okay, now let's see one more example. Let's do for starting with A. Number of string is starting with A, and you have to draw the regular expression for it. Draw it. Yeah, starting with A. See, starting with A, after it anything can come, no problem at all. That's it. This is a regular expression. Now ending with A. Ending with A. I should end with A only, and before it anything can come. Got it? Now let's draw for containing A. Let's do for containing A. See, I should have at least one A. Before it any number of times or any combination of A and B can come. After this also any combination of A and B can come. This is it. Got it? Now let's do one more example. Let's see. We have done the containing A part. Sorry. What if starting and ending with different symbol? What it means, if the string is starting with A, it should end with B. If the string is starting with B, it should end with A. Got it? So what it means, if I am starting with A, in between any combination of A and B can come any number of time, it should end with B. See, this is starting with A, ending with B. Or if the string is starting with B, then in between any number of B's or A can come in with any number of times, but it should end with A. This is it. Done. Starting and ending with different symbol. Got it? Now do starting and ending with same symbol. Starting and ending with same symbol or same input alphabet, whatever you want. So what will be the language present in it? Starting and ending with same symbol. Actually epsilon is also there because it is also starting with epsilon, ending with epsilon. A can also be there because it is starting with A and ending with A, same symbol. Starting with B, ending with B, or starting with A, ending with A, or starting with B, ending with B, and so on. How so on? A, B, A can also be, and so on. Got it? So the constraint is if the string start with A, in between anything can come, okay, but it should end also with A. Or if the string start with B, in between anything can come any number of time, but it should also end with B. Or A can also come, or B can also come, or epsilon. So this is the regular expression for this type of language. Okay.